Hello everyone, myself Mugdha Deshmukh, and today I'm going to present in front of you for Data Analytics Lab Oral Examination. My seat number is S1 90953018. Now, the outline of my entire PPT will be, first of all, I will be explaining what is data wrangling, then what is lasso regression auto analysis, what is the difference between the univariate, bivariate, and multivariate analysis, and then the use of the Seaborn libraries. First of all, what do you mean by a data wrangling? Data wrangling, it's sometimes referred to as data mugging. It is a process of transferring and mapping data from one row data into the another format with the intent of making it more appropriate and vulnerable for a variety of downstream purpose such as the analysis. The goal of the data wrangling is to assure the quality and the useful data. And so now I will be explaining data wrangling over here on Jupyter Notebook. So I'm sharing my Jupyter Notebook tab. Okay, so this is visible. Yeah. So data wrangling. So some basic part of data wrangling is how to assign a data, then how to form a data frame, how to merge both the data together. These are some of the examples of data wrangling processes. So first of all, we import pandas as PD, and then we are assigning data as data equals to in curly bracket name. I'm giving four types, that is name, age, gender, and marks. These four must be the column of my data. Okay, so in that rows, what must be filled is what given in square brackets. These all must be filled. And after assigning the data, now what I'm doing is I'm creating a data frame for the assigned data. How I'm creating is df equals to pd dot data frame in brackets data, and then df, that is, it is printing the data. And as I have already executed, but then again I'll execute it. Let's search that problem. Okay, so sometimes I'm having the net issue from my side, due to which it is not running. I'll go to the other part, that is the categorizing gender. Now, what do you mean by categorizing gender? Like, as I have mentioned in above, gender is whether he's male or whether he's female. So, instead of giving this M and F in string values, I am giving those values in a float. That whether if he's a male, then it will display 0. If he's a female, then it will display 1. And the type of this will be float, because if we'll type integer, then it will give us the error. Okay, so df in colon gender equals to df dot map, as I mentioned earlier. Now next will be I will import pandas as pd. This will be main. So then what I'm doing is I'm creating a data frame for a student detail. So what details a student might be having in the institute? His own ID, then his name, his branch. There are many more, but right now in this code, I'm specifying only these three types. Okay, and then I'm printing this detail in the same way how we have created first the data that was simply assigning a data, this one. And now what I'm doing is I'm creating the data frame with it. So how will it come? Details equals to PD, that is pandas, dot data frame, and then the entire content will come in that curly braces. And then I'm going to print the details like this. Let's see whether it is running or not. No, leave it as it. Okay, so I have printed the details over here. After that, I am creating a data frame for fee structure. That is whether the fee is pending, what is the pending status, fee pending status of the student. Okay, with ID. I'm giving it with ID here, like this. But not bad, sorry. Import pandas as PD, creating data frame for student details. So details equals to pd.data frame. Then fee structure, as I've given this two datas over here up, I'm again writing them over here. And then what I'm doing is I'm merging both the files. So I'm merging both the files in such a way that if we will see both the files, both the data frames, then what is similar in both the data frames is ID. ID is similar. That is based on that ID. What ID? That 101. The student containing the ID 101 is pending with 5,000 fee. Student with 102 is pending with 250 fee. But now, while merging, what I'm doing is I am printing direct. During printing only, I'm merging the file. pd.merge details, that is this first part, this entire first data, comma, fee status. Okay, merge details, comma, fee status. On ID means this ID will be 1 for both the data frames. Means in short, it got merged into each other. That is, this is the ID, this is the name of the student, this is the branch of the student, and this is the pending status of the student. It did, if I've not mentioned this over here, then what will it do? It will print the end, it will print the entire data frame as it is. That is, it will print the details data frame first, and then it will print the fee status second time. Okay, so this was the basic of the data wrangling. Now I'll again move on towards PPT. Finished with it. So what is over here? Data wrangling. As I mentioned above, it involves processing the data in various formats like merging, grouping, concatenating, etc. The main, what do we say, goal of data wrangling is to, what I can say, to have a quality of data with us. This is what we can say for this. Okay. So now third question, I have to explain the regression auto analysis. Okay, sorry. So this regression analysis, I'll explain you with the help of a Jamboard. Okay, so sorry for the inconvenience. So first of all, did what was my question actually? What do you mean by lasso regression analysis? So nowadays we can see that data is everywhere around us, right? In the form of spreadsheet or in the form of any of the surveys, or we can see on social media also. It also contains the data with it, and the process of cleaning, formatting, interpreting, analyzing, and visualizing this data is just to extract useful info, and through that info we can gain some valuable insights to make the effective decision, is what is called as data analysis. And this data analysis is organized into six types, and those entire six types are, first is exploratory analysis, second is descriptive analysis, then third is inferential analysis, fourth is predictive analysis, then comes the causal analysis, then comes the mechanistic analysis. So here in this video, what was my question was, I am really sorry because I directly jumped on second question. But no problem. Okay. So, in this question, I was having what is the difference between univariate, bivariate, and multivariate analysis? So, what is all these three things? These all three comes under the explanatory analysis. So, now what is EDA? It is a preliminary analysis of data to discover a relationship between measures in data and to gain an insight on the trends, pattern, and relationship among various entities present in the data set. With the help of statistic and visualistic tool is called as EDA, that is examine exploratory analysis. Okay. And now those types are univariate analysis, bivariate analysis, and trivariate analysis. So, what is univariate analysis? As the name suggests, uni means one and variate means variable. So, in univariate analysis, there is one dependent variable. The objective of this analysis is to derive the data, define and summarize it, and analyze the pattern present in it. Okay, and in dataset, it explores each variable separately. Okay, means each and every variable present in the data is analyzed separately for that. Then some pattern. It can univariate analysis can be described through various forms like frequency distribution tables, pie chart, histograms, frequency polygons, etc. Okay, this was what do we mean by univariate analysis. Okay. Then comes the bivariate analysis. Bivariate analysis, as the name suggests, bi means two, variate means variable. Therefore, it contains two variables. Okay, the relationship is between the two variables, and it helps to study the relationship between the two variables. Okay, So the results that are obtained from bivariate analysis are stored in data tables in the form of tables. Okay, and the table has two columns. As usual, we can say that if we are taking any two data, that is name and standard, then what will be? First will be standard column, then will be the name column. That is, we will be having it in the column format, two format. And the result that are obtained from BA are stored in data table. This data table itself is stored. Okay, bivariate analysis should be confused with two sample data analysis where X and Y variable are not related directly. If these two variables which we are taking, they are not related to each other, then this can confuse while using bivariate analysis process. Okay, so we should always be sure that while selecting the two variables, those two variables should be related with each other. BA is conducted by scattering plots, regression analysis, correlative coefficients. So this is what was my question, that is regression analysis. What is Lasso's regression analysis? Okay, then comes the multivariate analysis. It is required when more than two variables are to be considered, are to be analyzed simultaneously. So it is a tremendous hardest task for a human brain to do such tremendous hard task for so to visualize a relationship among four variables in a graph, and thus multi-analysis is used to study more complex set of data. Okay. So types of okay, I forgot to mention that bivariate analysis has three types in it. First one is the numerical and numerical type. Second one is the categorical type. And the third one is the numerical categorical type. Okay. And the types of bivariate analysis are sorry, not by multivariate analysis includes cluster analysis, then factorial analysis, multiple regression analysis, and there are more than 20 such different ways to perform multivariate analysis. And among these, which one to choose will depend upon what type of data we are having with us. Okay, so the unit difference between these uh, the main difference between these three analysis is main difference between these three is like their variables. Means you will use only one variable for the analysis, bi will use only two variables for the analysis, and multi will use three variables for this analysis. Then comes the Lasso's regression auto analysis process. So before directly jumping on Lasso's regression auto analysis, I will first try to explain what is linear regression. Okay, what is a linear regression analysis? Suppose that I am taking two parameters with me. Okay, suppose I am taking two parameters will be one is the experience and the second is the salary. Okay, salary. So just ignore my handwriting over here. Two parameters. I need to predict on based on my experience what will be my salary. Okay, So I need to do, I need this. So this is nothing but the number of experience I am having various points on graph. Uh, Here, various points on x-axis. Hmm. So there will be various points on my graph as experience. There are many people having some people might be having 1 year of experience and 2 years of experience, and this is 1, 2, 3, and so on. And based on this experience, what will be my salary? Now, suppose if I am testing a training data set. Okay, testing a training data set. Sorry, here I'm explaining linear analysis, a linear regression. I'm taking 2 points. Okay, this is my first point, and this is my second point. Assume. Okay, so like for these many experience years, I am having these much salaries, and for these much experience here, I have this much salaries, and I'm just drawing a line between them. The line is not straight. Leave. I'm just drawing a line between them. So what does this line mean? This line is the best fit example. Okay. So this is what is best fit example. But after selecting a best fit example, the next process is to calculate the sum of residuals. That is only nothing but a cost analysis. Okay. So what is a cost analysis for linear regression is sigma I equals to 0 to n. Okay. And then y minus y cap का square is equals to 0. No, sorry, not 0. Sorry. This is the sum of residuals. So what is this y over here? Y is nothing but this. Okay, if I'm considering this 1 point, then y is nothing but the amount of salary. And what is y cap? Y cap over here is this y equals to mx plus c over here. Okay. As both the points are on the best fit line, so this sum of residuals will always be equals to 0 in linear regression. Okay, so this will always be equals to 0. Next, when I am again considering these two only examples that I am supposed to uh, predict based on my experience what is my salary. Okay, and this time I'm taking the training set data. Then while taking a training data set, I'm having various data over here. Okay, so these are my various data over here. This is the main 2 points. I'm having various points over here. And as we saw from the formula for sum of residuals, that was sigma I equals to 0 uh, to n. At that time, but when I have taken the first graph, in this, I was having only 2 points with me. But right now, what the changes we are seeing, in with that 2 points, I am having more data with me. That is a training data set. But I can solve it. There is a difference over here. What I do? I have the best fit line with me. So I will plot these different data on that best fit line like this. Okay. By going this over here, this over here, this over here. But what we can see over here, there is a huge difference, right? So this is nothing but what we call as overfitting. And in order to reduce this overfitting, we are using the ridge regression or the Lasso's regression. Now, what is the difference between both? The ridge regression and Lasso's regression. There is a minute difference between these two terms. How? Now, there is formula difference just. That is, if we'll move towards understanding the ridge regression technique, then in ridge regression technique, for calculating the sum of residuals, we are adding one more term in it. That is lambda into slope square. Now, which slope square? This this best fit line slope square is what we are considering in uh, ridge regression as well as Lasso's regression. What is the formula for that? Sigma I equals to 0 up to n y minus y cap the whole square. This is square. Okay. Plus lambda into the slope square into slope square. Now, in rigid regression, there is slope square. Okay. But in case of Lasso's regression, it is modulus of slope. Okay, this is the major difference between ridge regression as well as Lasso's regression. Now, so what are we supposed to do if we saw the formula for that? Okay, as I explained, so here's my uh, experience, here's my salary, and I have the best fit line for that. Hmm. So what is the formula? Now, as we have seen in linear analysis, as all the points are plotted on the line, best fit line, therefore, this first term, that is sigma I equals to 1 to n, y minus y cap the whole square will be 0. Okay, as it lies on that line, therefore, it will always satisfy the equation of the line also. So it's 0 over there. But when in Lasso's regression analysis, we are adding these terms at lambda into slope square. At that time, we are getting some value for that. Now, slope, if my best fit line is like this, okay. So you can see that, wait a minute. If my best fit line is somewhat like this, then we can see that the slope is steepy. It means that the slope will be more, okay, and the value which will get as sum of residuals will be somewhat more. So and we are always supposed to reduce these values, and then we are supposed to uh, least value should be selected for this. Okay, and then we can consider that yes, this is my best fit line. So first of all, but if I'm considering this, suppose the slope of this line is 1.3. So first of all, 0 plus lambda value, I'm putting it as 1. It can be any lambda is always greater than 0 to any positive value. Okay. So for right now, I am taking lambda as equals to 1. 0 plus 1 into slope, my slope is 1.3, the whole square. Hmm. What will be this value for me? That will be 1.63. Okay. Whether you agree or you don't agree, this is what I'm taking the uh, assuming any value. Okay, this is what I'm getting. Then what will I do? I simply penalize this line. Okay, penalizing this line. That is, this is like this. Then I am taking this line with and plotting all the points on this line. Now, if the datas are over here, mine. Okay. Before these all datas were plotted on this line, right? Now these all datas will be plotted on this line. As you can see, the steepness of the line is reducing. So obviously the slope value will reduce. If the slope value will reduce at that time, the sum of residual will also reduce, right? So what will happen over here? It will reduce our sum of residuals, and with the help of this thing, we will get what we will get a best fit line for this particular two variables, right? Experience and salary. Now, oh, what happens in case of ridges? The slope gets shrinking in case of ridge, but in case of Lasso's analysis, sometimes while penalizing the slope, then we can get a time when the slope becomes equals to becomes not equals to, we can say, becomes somewhat closer to zero. But at that time, what we are doing is when the line is like this, like slightly coming towards. If we are having equations with many slopes, now as soon as the line is coming down, the more and more points are getting plotted on the best fit line. So we will have many slopes, that is y equals to m1 x plus m2 x2 plus m3 x3, like this. But what will it do? The least value will be minus, will be neglected in lassos. So it will directly be neglected and it will not be zero. Absolutely zero, it will not be in lassos regression, and we'll get a best fit line. Now I have explained my fourth question. I have also explained my third question, that is Lasso's regression. What is mentioned over here is an N1 penalty. What do we mean by this L1 penalty? Is penalizing the slope of the best fit line. Okay. Then was a difference between the univariate, bivariate, and multivariate. What is the basic difference between all these three? Is that univariate uses only one variable for the analysis, bivariate uses two variables for the analysis, whereas multivariate uses three variables for the analysis process. Question one. So this question one, I'm unable to present as my file is not running recently, but yes, if I'll get a chance to present this first question once again, I will surely present it with the entire data and all having with me. Thank you. Thank you, sir.